Hello everyone, welcome to the Gate Engineering online learning classes. In this video, we'll talk about some properties of the system. One is the causal and non-causal system. Second one is the static and dynamic system. So these are the some category in which system is defined. So first we'll discuss about the causal and non-causal system. Thereafter we'll talk about the static and dynamic system. In this video, a causal system is defined if the output does not depend on the future value of the input. It means that system is said to be causal if its output depends only on the present and or past value of the input. If system is defined by the future value of the input signal, if output of the system is defined by the future value of the input signal, the system will become non-causal system. Here we have some example of the causal system that we can see. A system is defined by yn is equal to 0.5 xn minus xn minus 2. This equation is called as our system because xn is our input signal and yn is our output signal. So here output signal yn is defined in terms of the input signal. Now we will have to check its dependability of the time. So output signal time is depends on the future value, past value, present value, that we will have to check. So let's we see yn is equal to 0.5 xn. So here we can see that xn and yn both are the same time. If we substitute n equal to 1, so we will get x1 here, y1 here. So this term is depends only on the present value of the signal. Okay. Now for this term here yn is equal to xn minus 2. So if we substitute n equal to 0, we will get x minus 2 here. If we substitute n equal to 2, we will get x0 here. If we substitute n equal to minus 2, we will get n equal to minus 4 here. So this term is for past value and first term is for the present value. So in this equation or in this system, output yn is depending only on the present and past value. So we can say that this system is the causal system. Now come to the second, yn equal to xn. It is clearly straightforward. Here this signal is depending only on the present value. Okay, so we can say that this system is the causal. Now come to the next point. Here yn minus 2 is the output value, which is the past value of the output. Now current value is the present value is the yn. That should depend only on the present and past value of the input signal. So here xn is the present value and xn minus 1 is the past value. So this system is also stable. Don't bother about the past value of the output. If system is depending on the future value of the input, then only system will become non-causal. Now definition we know, system is satisfying the system is said to be non-causal if output depends on the future value as well. So this is one example, yn equal to 0.5 xn minus xn plus 2. Here you can see that xn plus 2 is the future value. If we substitute n equal to 0, so we will get y0. So we will get y of 0 is equal to 0.5 x0 minus x2. So here you can see that time index is 0 for y and it is depending on the x2. So it means it depending on the second value, second index. So it is depending on the future value. So this system is non-causal. Similarly, if we see here yn minus 1 is xn, yn minus 1 for n equal to, let's see, for n equal to 1, if we check, so it will become y0, which is depending on the x1 value. So y0 is depending on the x value, that means output value is depending on the future value of the input signal. Similarly, here we can see that yn minus 5 is depending on the xn here. So it is again non-causal system. And y minus n is equal to 2 of xn. Okay, so we look at here, y minus n is equal to twice of xn. For n equal to, if we substitute n equal to 2, we will get y minus 2, which is depending on the 2 of x2. So we can say that this system is depending on the future value as well. Okay, minus 2 index is depending on the 2 index for the input. So it is depending on the future value. And one important thing is that for the causality or non-causality, we don't bother about the amplitude value. Just we need to check relation at the time index in the input signal and the output signal. Now we'll talk about the static and dynamic system. A system is said to be static if its output depends only on the present value of the input signal. Only on the present value of the input signal. If it is depending on the past value as well as future value, system will become dynamic. So if it is depending only on the present value, the system doesn't have any memory. This system doesn't consist any memory or energy storage element. So this system is called as memoryless system. Memoryless system. It doesn't contains any memory. So it is called as memoryless system. Any resistive network, all the elements are registered in the network or any circuit diagram. This system is called a static system because resistive is pure resistive element is pure static element because in the register there is nothing memory. There is no memory in the register. So pure resistive network is called as the static system. If there is any relation between input and output involving integrals or derivatives, the system will not become static. The system will be dynamic. So input output relation of such system does not have involve integrals or derivative. If we say that relation between input and relation between voltage and current in resistors V equal to IR by using Ohm's law. But if we talk about the capacitor, I equal to C dV over dt in the capacitor. So capacitor consists of derivative and integral. Similarly, inductor also consists of a derivative and integral. So in capacitor and inductors are the dynamic elements, but resistor is the static element. It doesn't involve the integral or derivatives. Now, dynamic system will become just opposite that. So static system depends only on the present value of the system, present value of the input. But in dynamic system is depending on the past value of the input and well as future value of the input. System will become dynamic, and it consists of the memory because it is storing some a past value and output is depending on the present past value of the input. So it consists of the memory elements. So this system is called as memory system. And electrical circuit system consists of capacitor and inductor in the example of dynamic system. In the example of dynamic system. Okay. If, in the input output relations are related with the integral or derivative or some differential equation, the system will become dynamic. Now, some relation between static and causal system as well as dynamic and non-causal system. As we know, static system depends only on the present value, and causal system depends on the present as well as past value. Okay. So we can say that all the static systems are causal system, but reverse is not true because some causal systems are depending on the past value, but that will become dynamic. But all the static systems, those are depending on the only on the present value of the input signal. So this kind of a system will become causal as well. Similarly, non-causal system depends on the future value only, but dynamic system depends on the past as well as future value. We can't say that dynamic systems are the non-causal, but we can say that non-causal systems will be definitely dynamic system. If the say one system is the non-causal, other system will become definitely non dynamic system. Here are some examples we'll discuss for the all the property of the causality and static and dynamic system. Yt equal to x square t. We don't bother about the square term here. Just we are focusing on the time index. So yt equal to x square t. So here yt is depending only on the t. That means depending only on the present value. So here it is depending only on the present value. So we can say that this system is causal as well as static. Now we come to the yt equal to half xt. This is the same condition depending only on the present value of the input. Here yt equal to xt minus 2. The xt minus 2 it becomes past value for yt. This is the past value. It means system is causal because causal system depends on the present and past value of the system, past value of the input. But dynamic system depends on the past and future value. So it is a dynamic system because it is depending on the past value. Now come to the xt plus 2, which is depending on the future value. So it is the non-causal as well as dynamic. Yt equal to x minus t, we don't bother about the negative sign. So as usual from as usual from the a and b, it is the causal as well as static. For yt equal to xt square, if we substitute t equal to 2, we'll get x4. For yt equal to, we will get x4. So it is depending on the future value. So future value, that means it is non-causal and dynamic. Now come to the next problem, x alpha t. If t x alpha t, if alpha is greater than 1, so it will depend on the future value. So it will become non-causal and dynamic. Because if, let's say, assume if alpha equal to 2, yt will be x2t. So definitely yt is depending on the future value of the input xt. So it is the non-causal and dynamic. Yt equal to txt. Here, this t is the multiplication with the xt, but we will have to check the function value, function index, which is t, independent variable t in x. So here yt equal to txt. So it is depending only on the present value. So this will become causal as well as static. Yt equal to dxt divided by dt. Yt equal to dxt divided by dt. So here this is the derivative signal. Derivative is always derivative is always causal but dynamic, because derivative consists of the initial value. Some memory is there. So the derivative is causal and dynamic because it is depending on the past value. If you see, we can write x of t with some x prime t with minus x0. That is the initial condition. Some initial condition is there, so it is depending on the past value as well. Now we talk about the integral. Integral here is starting from minus infinite to t, minus infinity to t, xt. So here minus infinity to t means it is depending on the past value. Yt equal to minus infinity to t xt. So this is the maximum limit is t. So it is depending on the present and past value. So it will become causal, but it is dynamic because depending on the past value as well. For the next question, upper limit is 2t, which is beyond the t, and it is depending on the future value as well. So it will become non-causal and dynamic. These are some problems that we have seen. These are some problems that we have seen for the causal non-causal system and static and dynamic system. Thank you for watching this video.